Good evening, student. So today we'll start our discussion on genetic algorithm. So we have already discussed the classical method. So now we can solve a nonlinear optimization problem using classical method. So you can either apply the Newton's method or Quasi-Newton method, steepest descent method. So these are some of the method you can apply for solving a multivariable nonlinear optimization problem. Now we also discuss about the difficulties or limitation of these algorithms, the classical optimization algorithm. So that we have discussed, but I would like to discuss it again. What is the difficulties we may face in solving some nonlinear optimization problem? This is an single variable function. So this is a single variable function, and if you look at this particular function, so we have several optimal solution. So what is optimal solution, or if you can say that stationary point? The stationary points are that the gradient is 0. Okay, so if you look at, so these are all maximum point, and if you look at, so there are several optimal solutions. So this is one solution, this is one peak, this is one peak, this is one peak, and this is one peak. So if I go by definition of local and global optima or global maxima, so you can see that there is a solution which is basically the base solution within the search space. So here search space is suppose from here, from this point to this point. So this is the search space. So within this search space, so there is a solution, and this is basically the global optimal solution. So you can say this is a global optimal solution. And if you look at the other solution, so they are optimal solution, but they are local optimal solution. So you have these 1 2 3 4 local optimal solution, and total there are 5 optimal solutions, and out of 5, 4 solutions are local optimal solution, and one of them and one solution is global optimal solution. So that is the global maxima. Now is the thing that you want to apply classical method for solving this problem. So in classical method, what we do basically, we start with a starting point. We start our algorithm with a starting point. We call it initial point x naught. Okay, so now if you take x naught, suppose somewhere here, suppose if I take x naught somewhere here, suppose, so probably I will get this optimal solution. If I take x naught somewhere here, I will get this optimal solution. Similarly, if I take x naught solution, x naught here, so I will get this solution, and if I take x naught here, so I will get this solution. But luckily, if I take my x naught somewhere here within this, so I may get the global optimal solution. So therefore, the classical optimization method, so they are sensitive to the initial solution. So now question is that when you are solving, you do not know if you have multiple optimal solutions. So in that case, you do not know what should be your correct initial point, so that you get the global optimal solution. Now if you want to solve this problem using classical method, I'm not telling that you cannot solve this problem using classical method, but it is difficult. So what is the criteria, or what you should do basically? If you have more than one optimal solution, then you just change your starting point. So randomly you take a starting point between lower bound and upper bound, okay, and then you try to get the solution. So if you have multiple optimal solution, then you just take different initial solution, and then you try to get the solution. So every time you should get a different optimal solution, and one of them may be the global optimal solution. So that way you can try, and you may get sometime, if you are lucky enough, then if you are getting the appropriate initial solution, then you may get the global optimal solution. But I think you can suppose you have understood that the problem is not that easy, because I don't know what should be the initial solution. So therefore this types of problem when you have multiple optimal solution and one of them is your global optimal solution, then this is really difficult to solve using classical method. So this is a two-dimensional problem. So if you look at the first problem here, so I think already we have discussed, so you know what is optimization. Okay, so optimization is the act of obtaining best result out under a given circumstances. So already we have discussed, and it's a mathematical discipline which concerned with the finding of maxima and minima of a function, and probably you have some constraints. Okay, now if you look at this three function I have shown here, the first function is basically a convex function. So here whether you are taking a initial point here, here, or here, so you will get the global optimal solution, or there is only one optimal solution. So we call it unimodal function. It's a convex function and there is only one optimal solution, and you just apply classical method. So whatever may be the initial solution within the search space, so every time you will get the global optimal solution, or that is the basically local or global, there is only one optimal solution. Now this problem is relatively your simple problem. Okay, so we call it convex problem. So already we have discussed what is convex problem, what is non-convex problem. So this is a convex problem, and you can apply the classical method and you will get the global optimal solution, or local optimal solution. There is only, as I said, there is only one optimal solution. So this is, I can say, this is an easy problem. So this is an easy problem. So this is an easy problem. Okay, so this is an easy problem, and basically, so you can apply the classical method. This is a convex problem and you can apply the classical method to solve this problem. I hope this is clear to you. Now second problem is basically little bit difficult problem, because there are four optimal solution here. So now if I take an initial point somewhere here, maybe you may get this optimal solution. So if you take somewhere here, you may get this. If you take somewhere here, you may get this, or if you take somewhere here, you may get this optimal solution. So here what will happen, depending upon what initial solution you have taken, so every time you may get a different optimal solution. So now for this function, I think all are low, means there are multiple optimal solution, and basically you will get one of them depending upon what initial solution you have chosen. Okay, so this is relatively difficult, but still I say because there are only four optimal solutions, so probably if you are doing some iteration, so you may get all of them basically in using classical method. Now question is that then go to the third one. Third one is quite difficult. So there are innumerable your solution, local optimal solution, and one of them is the global optimal solution. So now if you look at this particular your function, so this is not easy to solve using classical method. So you can try, maybe you need 1000 iteration, or maybe you need more than that iteration to get the your global means local optimal solution of the problem. Okay, so this is basically it is not an not an easy way to solve using or it is not that easy to solve this problem using classical optimization technique. Okay, so you need some different method. Okay, so this method we'll discuss today. So one of them, as I said, this is genetic algorithm, so I can use genetic algorithm for solving this problem. So I hope now it is clear. So I will not suggest basically that if your problem is the first problem, means your problem, if I say this is problem 1 and this is 2 and this is 3, so certainly I will say that for the first problem you apply classical method, for the second problem also you can apply classical method, but you can apply non-classical method, and for the third problem you should apply the non-classical method. Okay, so it is difficult to solve this problem using classical method. So I can say that first one is easy to solve by classical method, so you apply classical method. The second one is relatively difficult to solve by classical method, but still you can apply classical method, so with some iteration probably you will get the solution. But third one is difficult to solve by classical method, so therefore you need some different algorithm to solve this type of problems. Okay, so you need some different your algorithm to solve this type of problem. Now, what is principle of natural evolution? Okay, so what is happening in nature? That if you look at the evolution cycle in nature, so what we are doing, suppose this is the struggle for existence, that is survival of fittest. So what is there basically? So you are struggling to survive. Okay, and what is the natural law? That is basically the survival of fittest. The fit will survive. Those who are not fit, they will be eliminated from the from nature. So now this surviving individual, so you can say that one is struggle. Okay, so struggle for existence, so that is you're struggling. And second one is surviving individual reproduce, those who have survived in that particular environment. Okay, so if you change the environment, again the surviving characters may change. So surviving individual reproduce, propagate the favorable characteristics to their offspring. Okay, so what is doing that? Whatever those who have survived in nature, so they will basically reproduce. Okay, they will produce offspring, and they will transfer, or they will basically propagate the favorable characteristics to their offspring. So this is basically, we call it evolve species. So I will give you an example in the next slide. So I will give an example, and then then basically it is starting with a population. So if I look at that, what is happening in nature, so it's a population. Okay, so you are, then whatever population, they are struggling for existence, that is survival of the fittest. Then this surviving individual, they reproduce and propagate their favorable characteristics. So I will give an example, and this is basically, we call it evolve. The species is evolve. Okay, so the law is this is based on principle of natural selection. That means select the best, discard the rest. So best will be selected and rest will be discarded. Okay, so select the best, discard the rest, discard the rest. Okay, so this is basically what is happening in nature. Now question is that, now whatever this process is going on, okay, whether this is a random search process or guided search process. Now question is that, what is random search process and what is guided search process? Random versus guided search. So now I can give you an example problem. Okay, suppose you have total these four your word, sorry, you have these four letters. This letter is basically OLZA. So and basically these letters are with you, and basically you are asking somebody to make the word goal. Okay, so GOAL, goal basically. Now question is that, again I can mean, suppose, because you can look at it, so you can if I ask you that, okay, you take these four blocks and make the word goal, so you can do it. But if I put a blindfold on your eyes, if you cannot see basically, then I am asking you that, okay, you just arrange this letter in such a way that you are getting the goal word. Okay, now how we'll do that basically? So what you will do basically, so I will only give you one, I will only give you the one signal, that is yes or no. That means if you are getting the word, then I will say yes, you got the solution, or otherwise I will say no basically. Apart from that, I will not give you any your information during the search process. So now what you will do basically, so you will arrange this for in that, then you will ask whether it is a letter the word goal. Then okay, no, then what next you will do, you will rearrange this letter, and again you will basically ask yes or no basically. So now you just see how much time it may take to get the solution is the letter you have to arrange in terms of in basically the in goal basically, so GOL in that sequence. So now how much time it may take. Now this is basically purely random process. So what you are doing basically, so you are selecting and then you are putting you are showing this thing, and then there is no your interlinking, or there is no influence from the previous your process and this process. So what I'm telling here, suppose first time you are arranging this letter, then you are putting it, then next time whatever event you are or whatever selecting, so it doesn't have any influence to the previous event. So therefore this is a purely random search process. So you are just taking the letter and you are showing that this is goal basically. Now next is, suppose if I give you a little bit more information to you. What information? Some information that the first letter is correct, okay, or first your second letter is correct, okay, something like that. If we provide some more information to you, so in that case you will be able to find the solution in a little bit quicker way. Okay, so if I say that first time you have shown this letter, I am telling that okay, the first letter is correct, then what you will do basically, you will fix the first letter, so you will not change the first letter next time. So you are fixing first letter, then you are doing the iteration with the three letters. Okay, so then once you are getting second or fourth letter, so I'm telling okay, the fourth is correct, then you are fixing one and fourth, then you will try to rearrange the second two. So in that way you will get the solution in a much quicker way. So now if you look at these two processes, the first process, there is no information, you are just arranging this thing, I'm telling that yes or no. And in the second case, what you are doing, you are basically getting some more information. So you are getting whether first one is correct or second one is correct. So in that case the second one will be quicker, and that is basically, we call it guided search. The search is guided. Who is guiding? I am guiding. I am telling that okay, this letter is correct. So now this is the difference between your random search and guided search. So somebody is guiding. Okay, so the first trial I'm getting this, so I'm just telling it is your no. Then basically second try, so you are getting, so I'm telling that okay, Z is correct, okay, the first one is correct. So then you will try with the basically you will try to arrange the other letter. Okay, so this is basically the guided search. So now our genetic evolution process, whether, as I said, that whether it is a random search or it is a guided search, so certainly it is not a random search. Somebody is guiding. Who is guiding? Nature is guiding. How it is guiding? That nature is guiding with some law basically, that select the best, discard the rest. So fittest will survive. Okay, those who are fit, they will survive. Those who are not fit, they will not survive. So it is guided by some law of nature. So this is not a purely random process. Okay, so this is a guided your process. Now, let us take an example of this thing. So, giraffe, I think you have seen giraffe, and giraffe has a very long neck. Okay, so I think whatever I have seen, but some evidence are telling that giraffe, I think millions year back, giraffe didn't have long neck. They had actually shorter neck. So, giraffe. So now what is happening, there may be little bit of because of mutation or something. So some giraffe, okay, so in a particular some giraffe may have little bit longer neck at that time. So giraffe with slightly longer neck could feed on leaf of higher branches when all lower one has been eaten off. So now what is happening, that those who are basically little bit your longer, so this is a favorable characteristics. Okay, so the taller one, a longer neck one, so they can actually take the leaves from the higher your branches. Okay, once this is so, now what is happening, this is a favorable characteristics. They had a better chance of survival because they are also getting food from the higher leaves, so they have a better chance of survival. And as I said, this is a favorable characteristics, and this characteristics has been propagated through generation of giraffe. So this favorable characteristic is going to their offspring, and it is propagating, and finally what is happening, so now whatever we are getting, this is the species has long neck. Okay, so the species has long neck. So that is basically we can see. So this longer neck may have due to the effect of mutation initially, as I said that this is basically the mutation, some mutation, because of mutation some giraffe initially had longer neck. However, as it was a favorable, and this was propagated over the generation. Okay, so this is propagated over the generation, and basically yeah, so this has been this has been going, this favorable characteristic has been you're going generation to generation, and whatever you are looking at, suppose that giraffe with longer neck. I can give you another example problem. Suppose we are living, suppose at an altitude of maybe 50 or maybe 100, something like that. So now air pressure is different here, so when you are living at altitude, now if you look at that, if you want to go to an altitude of 5,000, 15,000, or 20,000, so what will happen basically, so there the pressure and temperature is different. Okay, so that is a different environment. Now if we put what happens, suppose if you are putting 100 people or 100 animals from this area, so altitude of 100, suppose, and we are putting them in altitude of 15,000 or 15,000 feet, or something like that. Now what will happen, so they will go, and once you are putting that one, so some of them may not be able to survive in that particular environment, and they are not fit to live on that particular environment, so they will basically die out, and some people will basically able to live with at that environment with actually reduced oxygen level. So oxygen level at that your is very less, so you can actually, some people may be able to survive, okay, with less oxygen, and some people will not be able to survive with less oxygen. So now what will happen, that is a favorable characteristic. Those who can survive with less oxygen, that is a favorable characteristic, and they will survive. And what will happen, if they are staying there, they will propagate this favorable characteristic. What is the favorable characteristics there? The characteristics is that they can survive with less oxygen. Okay, so in that case, they will be basically, that will be propagated, and basically, so in new species will come, and these species can live in that high altitude with lesser oxygen level. Okay, so this is basically how we are adapting with the nature. Okay, so it's called adaptation. I hope this is clear. So Darwin's principle of natural selection, what it is telling. Okay, so finally, if there is an organism that reproduce, okay, so reproduce, they are producing their offspring. If offspring inherit character from their progenitor, so they have whatever characteristic of the offspring, so it is coming from their parents. Okay, so that is from their progenitor. Okay, so if there is a favorable character, so out of them whatever characteristics is propagating to their offspring, if there is a there is a variability of character, so it's not that everybody will have the same your character, and if the environment cannot support all the member of the growing population. So I just said that one, that if you're putting 100 people at an altitude of 15,000 or 20,000, so and all of them have variable characteristics. Okay, some people can survive with less oxygen, some people cannot survive with less oxygen. So what will happen if the environment cannot support all the member of the growing population? So okay, so in that case what will happen, then those member of the population with less adaptive trait will die out. Okay, so some of them will die out, so who is not fit to survive in that particular environment, and those member with more adaptive character will be flourish. Okay, so they will be able to survive because they can live with, as I given an example, so they are living with less oxygen, so they probably will be so they will flourish basically. And this is basically this is results in evolution of species. Okay, so now what we have seen here, if there are organisms that reproduce, if offspring inherit characteristics to from their progenitor, from their parents, it is coming to the offspring. If there is a variability of character, that means character is not same, as I said that some people can survive with less oxygen, some people cannot survive, so it's a variable characteristic. If the environment cannot support all the member of the growing population, if there is a this is your struggle for existence, and in that case those member of the population with less adaptive trait will die out, and those member with more adaptive character will flourish. Okay, and this is the evolution of species. Okay, so this principle basically we will apply in case of genetic algorithm artificially. Okay, so what is happening in nature, this natural evolution process, so what is happening in nature, so that we will try to apply artificially for solving an optimization problem. And this is basically we are discussing the genetic algorithm part. So genetic algorithms are heuristic search, okay, an optimization technique that mimic the process of natural evolution. So what we are doing, we are trying to mimic the process of natural evolution. So what is happening in nature, and that artificially we are trying to mimic that one, and for solving solving an optimization problem. Genetic algorithm implement the optimization strategies by simulating evolution of species through natural selection. So we are trying to simulate artificially the evolution process and for solving an optimization problem. Okay, so this is basically all about your philosophy of or concept of genetic algorithm. So from where it is coming, it's coming from natural evolution. So people have observed the natural evolution, and they are saying that okay, every iteration we are getting some better trait. Okay, and that is basically, so with some millions of iteration probably we reach this particular stage, and this is actually continuously it is evolving. But question is that you can see last your suppose if you look at last 500 years, 1000 years, or something like that, there is no sense in that evolution process, but this process is very slow. It may take millions of years to reach this particular your level. So maybe after some millions years again this species will have a different your types basically. So this is and as I said, so we are trying to apply artificially, and we are trying to apply the natural evolution process for solving the optimization problem. So history of genetic algorithm. So evolutionary computing was introduced in 1960 by Rosenberg. Okay, Rosenberg. So the concept was given in around 1960, but at that time it was not very popular. and people didn't accept it as an optimization technique. Still, I think there are two schools today also, and some people are saying that these are not optimization method, but some people are saying this is very powerful optimization your technique, so which cannot be solved using classical method, that can be solved using this non-classical or meta-heuristic optimization technique. Now John Holland, so he wrote the first book on genetic algorithm, that is Adaptation in Natural and Artificial System, in 1975. So and this is basically he is the first person to wrote a book on genetic algorithm. And then basically in 1992 John Koja used genetic algorithm to evolve programs to perform certain tasks. He called this method as genetic programming. Okay, so this is also this is not genetic algorithm, but this is an evolutionary computing, and genetic programming is one of them. And John Koja was pioneer on that particular work. Okay, yeah. So then David Goldberg, who was a student of John Holland, and he actually wrote a book on genetic algorithm in search optimization and machine learning, and it is one of the most popular book or best-selling book in around 1989 or something like that. So the David Goldberg, as I said, that he was a student of Professor John Holland, and he actually popularized the genetic algorithm. Okay, so after this book, after his book, genetic algorithm become a very popular your algorithm, and many people have accepted this algorithm for solving optimization problem. Now let us see what is simple genetic algorithm. Okay, so basically, if you look at this, I will give you the algorithm, and then I have given the function. So it is start with some solution, so we call it population. Okay, start, so it is basically start with initial your population. So now the difference is here with the classical method. In classical method, what we do basically, it is starting with a single single initial point. So okay, so you are starting with a single solution, but here what you are doing, you are starting your iteration with an initial population. We call it population because in Nasser it's not one to one, basically, that from one parents to one offspring. It's not like that. It's a population from one population you are getting a next generation. So we call it population here, so initial population. And then evaluate the solution. So evaluate the solution means the fitness of the solution, how strong that solution, how good that solution is, basically. So that you evaluate. So as I said that in Nasser, what is happening, that those who are strong or fit, they will survive. Those who are not strong or not strong, favorable for that particular environment, they will be eliminated from the your process. Okay, so evaluate the solution. Okay, so this is one process. So once you are getting the initial population, then evaluate how good that this solution are. How to evaluate? So based on the objective function value, basically. Okay, so we will evaluate this thing. Now then there is an your criteria, that is it an optimal solution? Are you getting an optimal solution? Okay, if it is yes, then stop, and basically you declare that okay, so you are getting an optimal solution. Yes, but if it is no, okay, so then what you will do, it will go through the some your operators. Okay, so these operators are selection, crossover, and mutation, and these operators are exist in Nasser. In Nasser also this is happening. Okay, so when they are going through this operator in Nasser, so then only, so as I said, that who will pass through this operator, and they will be able to survive, and they will go to the next generation. And those who actually fail to go through this operator, okay, so in that case they will so they will not be able to survive. Okay, so in that case, that is not yeah. So now they will go through this operator selection, crossover, and mutation. So I will discuss these operators one by one, and then so this is the generation. It will go to the solution which is passing through this operator. So they will go to the next generation, and this basically this will continue. This will continue until you are not getting the termination criteria. So in Nasser, this process is continuing, is not it? So this process is continuing in Nasser, but in case of optimization problem, so you cannot continue for up to infinity. So you cannot continue this loop. So somewhere you have to stop this iteration. So when you will stop it, that is basically, is it optimal? So we will put some termination criteria. Okay, so based on that termination criteria, so your iteration will be terminated. So it's not that we'll just iterate it just like in Nasser. So Nasser is not, there is no termination criteria. It is happening now, also it is happening. Okay, but in case of optimization problem, you need a solution. So you have to terminate your iteration. Okay, so there are some criteria I will discuss. So one criteria may be you just think the one criteria is the number of iterations. Okay, so I will iterate it for 100 iteration. Okay, so this is one criteria maybe, and there may be criteria that optimal solution is not changing. So whatever optimal solution, that is the generation based solution, that every time you are evaluating and one of them is the best solution, and this best solution is not changing for some time. In that case, and that is also you can define, suppose for 50 iterations that best solution is not changing, that probably you got the optimal solution and that's why it is not changing. So therefore you can terminate your iteration. So there may be some different termination criteria, so we will discuss them in some in subsequent slides. And but you just one criteria may be generation, that I am putting maximum generation, that I can go up to 500 generation, 1000 generation, 1 million generation, something like that I can put. And I can also put that your optimal solution is not changing, that is the best solution is not changing for some iteration, maybe 100 iteration or 50 iteration, it is not changing, then probably you are getting the optimal solution. Okay, and then basically you will stop. Okay, so you will stop your iteration. Now in the, so I'm giving you the pseudocode here. So function SGA. What is SGA? Simple genetic algorithm. So this is the function SGA. So if I write the pseudocode, what you will do basically, initiate population, calculate fitness function, and then so this is the initially you are doing these two steps, and after that you are putting in this particular loop. Okay, so while fitness value is not equal to termination criteria. Okay, so termination criteria, and then what you are doing, your solution will go through this operator selection, crossover, mutation, and we will calculate the fitness again, and this iteration will continue till you are not getting the termination criteria. So you are not getting the termination criteria, so you will basically complete this iteration. Okay, so this is your sample genetic algorithm. So I will also do a hand calculation. So I will show you these processes. Okay, so using some hand calculation, I will show you that one, and then this iteration will continue till you are not getting the you're not meeting the termination criteria. So let us discuss these operators one by one. So how many operators? There are three main operators, that is selection, crossover, and mutation. So these are the three operators, and then whatever initial population you have generated, this solution will go through this selection, crossover, and mutation operators. Okay. Now we'll discuss these genetic operators one by one. So we'll discuss them. The first one is the selection operator. So from where this selection operator is basically coming, and what is the function of this selection operator? So selection operator is coming from the Darwin's principle. What is that? That is select the best, discard the rest. Okay, so select the best, discard the rest. The process that determines which solutions are to be preserved and allowed to reproduce, and which one deserve to die out. So this is the purpose of selection operator. Okay, so which solution will basically preserve or allowed to reproduce, and which solution will or which one deserve to die out. Okay, which one deserve to die out. So that means they will be eliminated from the selection process. The primary objective of the selection operator is to emphasize the good solution and eliminate the bad solutions in a population while keeping the population size constant. I hope this is clear. So what we are doing basically, so the principle is that you are trying to you are emphasizing on the good solution and trying to eliminate the bad solution, and at the same time I have to maintain the constant population size. Okay, so that whatever population size we had actually earlier, same population size we will maintain, but we will try to eliminate the bad solution. So function of selection operator: identify the good solution in a population. So this is basically from where you are getting from the the fitness function. Okay, so then make multiple copies of the good solution. So we are making multiple copies, so they are good, so they should have more copies. Okay, and eliminate bad solution from the population. So this is basically the function of a selection operator. Now I can apply any kind of, suppose operator, so which will basically have this type of which will basically fulfill this function. Now how to identify good solution? So let us see how we can identify good solution. So for identifying good solution, what I need a fitness function. If fitness value can be assigned to evaluate the solution, is not it? So suppose a particular solution, so I want to give a fitness function, that fitness function will assign a value to evaluate that solution. Okay, based on that value I can say that this solution is good, this solution is not good, this solution is relatively good, or something like that. So I can do that using fitness function. A fitness function value quantifies the optimality of a solution. Okay, so this value is used to rank a particular solution against all other solution. Okay, so this is the fitness function. If fitness value is assigned to each solution depending on how close it is actually to the optimal solution of the problem. Okay, so this is basically the function of a fitness property of a fitness function. So we are assigning some value because we are working with some an optimization problem. Okay, so to quantify whether that solution is what is that the fitness of that particular solution, so we have to assign some number, and this number is basically given by this fitness function. So assign a fitness function. So let us take an example problem. So this is an example problem. We suppose minimize f is a function of dh. So this is a can optimization problem. Okay, so what you want to do, that you want to minimize the cost of this particular can. Okay, so I want to have a optimal dimension of this can, and which will basically having less cost. Okay, less cost means less your surface area. Okay, and multiplied by some your cost value will give you the cost. So basically what we are doing, we are trying to minimize the surface area of this can. Okay, so surface area is basically that your total surface area is given by this equation. So this is the surface area multiplied by cost per unit area. So this is C, and there is a constraint here. The constraint is the volume should be 300 ml. Okay, so volume is greater than 300. Okay, so this volume should be, so I would like to have a dimension of this can, minimum dimension which will give you minimum surface minimum cost you can say, and then volume is more than 300, and there is some upper limit and lower limit of the dimension, that means diameter of the can and at the same time height of the can. Okay, so this is, and now I can say suppose C equal to this, C equal to 0.0654, and for 0.0654 I am getting, suppose if the dimension is 8 or 10, that means your D equal to 8, and this is D and this is 8. Okay, diameter is 8 and 8 is 10, so what I am getting, I am 23. So 23 is the cost function value. Okay, so what we are doing here, we are trying to find out minimum cost. That means if this number is minimum, then that particular solution is a better solution. So you can say that this is the fitness function. So fitness function is this, and I'm getting here in this a numerical value. So if some value is 22, so 22 will be better than that. Okay, if you're getting 44, 44 is basically 23 is better than the 44 solution. So depending on this number, you can tell actually that whether your solution is your better solution or worse solution or inferior solution. You can say that one looking at this particular number. So that way I can assign a fitness function. Okay, so in this case this is a minimization problem, so therefore I can tell that I can say that if the fitness function value is your less, so in that case the solution is better. But if you're thinking that this is a little bit confusing, because here less mean better or more means inferior, so you can convert this function. Suppose I can convert this function that this is 1 by 1 plus f basically. So in that case, if f is more, that means function that solution is better. In f is less, the solution is better. So I can also convert your fitness function something like that. But for this particular problem, let us go ahead with this concept that if the f value is less, the function value is less, that means the solution is better, and if function value is more, then the solution is inferior. Okay, so with this concept, so I am defining or assigning a fitness value. Now what selection operator will do basically? Okay, so there are different techniques to implement selection in genetic algorithm. So we have different techniques, and some of them are tournament selection, roulette wheel selection, then proportionate selection and rank selection. So we'll discuss one by one. These are the some of the selection operators. Okay, so you can implement one, means one of them you can implement. There are some other operators also, or you can also define an operator. So basic function is that I am trying to find out the better solution, and we'll have multiple copies of the better solution, and then I would like to eliminate the inferior solution. Inferior solution will be eliminated, and I will try to preserve the population. So if your initial population is 10, so I want to maintain the 10 solution when you are eliminating the inferior solution. So this is basically your selection operator. Okay, this is the function. So I can apply this tournament selection, roulette wheel selection, proportionate selection, and rank selection. There are some other selection operators, so I'm not discussing here, but there are some other selection operator that also we can apply. Okay, so what is tournament selection? Tournament selection, the concept is very simple. So what we do basically in tournament, so what in tournament, several tournaments are played among a few individuals. Suppose there is a boxing tournament. Okay, so what you are doing basically, there are two person, so they are fighting each other, and one will be winner after some time. Okay, so one will be the winner. So basically, so he is the better solution, so therefore he is he's winning that particular tournament. So what is tournament? A tournament, in tournament selection, several tournaments are played among the few individual. Okay, so it may be one, means two individual, it may be three individual, it may be three, or it may be four. So, but one will win out of out of that individual, one will win the tournament, and the individuals are chosen at random from the population. So what I'm doing, I'm explaining this thing. The winner of each tournament is selected for the next generation. Selection pressure can be adjusted by sending the tournament size. So selection pressure also I will discuss. What is selection pressure here? Suppose you have total in suppose minimum 2 person is required to play the tournament. Now if you are putting 3 4 5 like that, the selection pressure will increase. I will discuss with when I'm discussing the other thing. I will discuss what is selection your pressure. So weak individual have a smaller chance to be selected if the tournament size is large. That is basically selection your operator. So the weak individual, so if you are, suppose if I am selecting what is happening, suppose 10 your solutions are there and tournament size is 5. So in that case what will happen, that basically the best 2 solution will may win the tournament or something like that. So that weak individual, so because they will not be able to suppose win the tournament. Okay, so they have a smaller chance to be selected if the tournament size is large. Okay, so I am giving an example problem. Suppose I have few solutions, suppose total 8 your solution, and out of this 8 solution, so I am taking 2 solution at a time. Okay, so this is basically suppose I'm picking 2 solution, and here one solution is 22. So this 22 is giving the fitness value 22, and second one is 13, but 13 there is a plus 30. What is plus 30? This is a constraint violation. If you recall that that the volume should be equal to 300, but in this case because can size is small, so you cannot take a volume of 300, or it is taking 270. So now this 300 is, that solution is not acceptable to me because it is violating that particular constraint. So therefore I am adding that 330 there, so that it is not selected, because I don't want to, because that is an inferior solution that is basically violating the constraint. So I don't want to select that solution, and therefore I am putting the violation, though the cost is less 13, but that is not acceptable solution because it is violating the constraint. So therefore I am adding plus. So if you play tournament between these two, which one is better? 22 is better because it is not violating the constraint and at the same time cost is small. So 22 is the winner in this case. Now there is a tournament between 32 and 40, so certainly 32 is better in this case, so 32 is winning the tournament. And then there is a solution, so here again 7, so cost is very less, but it is violating the constraint by 45, so therefore that is not an acceptable solution. So acceptable solution is 25, so 25 is winning the tournament. So what I'm doing here, we have total 8 solution, 1 2 3 4 5 6 solution, and out of 6, so if I take a tournament size of 2, then how many tournament you can play? 3 tournament, and 3 tournament means 3 winner. So you are getting from 6 solution, if you play 1 round of tournament, you are getting 3 solutions. So in this case the 22 is playing with 13. Okay, so 22 is winning, 32 is 40, so 32 is winning, and 45 with 25, 7 with 25, 25 is winning. So this is the first round. That means everybody has participated in the tournament and you are getting 3 better solution, 22, 32 and 25. So you are getting this 3 your solution, which will go to the next generation. Now what we need basically, because it's I have to have a same population, that means 6 population I have to have. So what I will do, I will play the tournament again. So this time again I am picking 2 solution randomly. So now what is happening, 32 is playing with 25, so 25 will certainly win because that is the better solution. Then 40 is playing with 22, so 22 is the better solution, so 22 is winning the tournament. And then 7 and 13, so now what is happening, this is both are infeasible solution, not acceptable solution. But if you look at the violation, that means the violation of this is less, 13 plus 30, so therefore the tournament, that less constraint violations solution will be selected. Okay, so you are getting this solution. So how many solution you are getting? In the first iteration you are getting these 3 solution, and the second tournament you are getting this solution. So I am getting these are the selected your population. So you just look at this. So you have started with 6 solution. Now you are getting 6 solution, but what is the difference here? The difference here is that the worst solution is not there. Which one is the worst solution? Worst solution is this. Okay, so this is the worst solution and that is not there. Okay, and if you look at another characteristics, the best solution, which one is the best solution? 22. And the best solution is basically we'll have two copies here, because both the time he will win the tournament. Whether he's playing with anybody, he will win the tournament. So first time also he basically won the tournament, and second time also. So therefore it has basically 2 copies, and other may have 2 copies and 1 copies depending upon who is playing with what. Okay, so therefore finally I can conclude this part. If you are applying tournament selection, best solution will have 2 copies, worst solution will have no copy. Okay, so worst solution will be eliminated, because whether he is playing with anybody, he will not be able to win. Okay, so therefore he will not have any copies. And the third point is the other solution will have either 0, 1 or 2 copies. So if they are, suppose there may be 0 copies, because suppose a particular solution he is playing, both the time he is playing little bit with better solution, so he will have 0 copies, but by luck he is playing with an inferior solution, he may win. So therefore they may have 0 copies, 1 copies and 2 copies. So you can see that 25 is having 2 copies. So 25 is not the best solution, it is a mediocre solution. But what is happening, both the time he is playing with an inferior person, he is not playing 22, is not playing with 25 is not playing with 22. So in that case 22 would have suppose 25 would have been a single copy, but he is playing, suppose first time he is playing with the invisible solution, so he won the tournament, and second time he is playing with 32, so that's why we have your 2 copies of 25. And as I said, that other solution may have 2 copies or may have 1 copies. So then let's stop here today. So we'll continue our discussion on genetic operators in the next class tomorrow. I hope the concept is clear to you. And anyway, so if you have any confusion or any question, so we can discuss it tomorrow. So let's stop here. See you tomorrow.